All right. I should be done in a few minutes. We've got an opaque urn. Opaque means you can't see it. An urn is like a vase kind of thing. All right, let's see. 8 red, 6 white, 4 blue ping pong balls. The probability that you get a red, you don't replace it, and you get a blue. The probability you got a red, there are 18, it would have been 8 out of 18. You do not replace it, probably you get a blue. There are still 4 blue, but there are now only 17 left. And that's the probability, say it sure is.
Sure it is.
All right, let's see. The suits in the deck of cards are hearts, spades, diamonds, clubs. There are 13 of each. All right. Probability. You pick a heart, then a heart, then a club. 3 in a row with no replacement. No replacement. Pick a card. You pick a heart. How many hearts are there? 13 out of 52. You do not put it back in the deck. You pick again. How many hearts are left? 12 out of 51. Now you hope you pick a club. How many clubs are left? 13 out of 50. Awesome, 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 awesome. Everyone okay back there? Violence? Okay. All right. There are 1,000 athletes that go to a camp in Kansas City. 400 fly. They fly on an airplane. They aren't able to. They're not good enough. They fly airplane. And let's see. And 700 of them are soccer. So it's a variety of different sports. Even before we have questions, it's not a bad idea to make a chart. We are talking about people that fly to the athletic competition or that did not fly. And we also are talking about people at this camp that went for soccer and people that were not there for soccer for some other sport. All right. And let's say this, 1/4 of those who fly do not play soccer. And there's your one little mathematical hint on that. All right, 1/4 of them that fly do not play soccer. What is 1/4 of 400? 100 flew and not soccer. Fly, not soccer. All right, let's see. So how many flew? A total of 300 would be in here. Our total number of soccer was 700, so we have 400. There were 1,000 athletes. 3, 4, 8, so there'd be 200 here. And now a question might be the probability that somebody flies or soccer. Probability they fly or soccer. So the probability they fly would be 400 out of 1,000. Added to probability they played soccer would be 700 out of 1,000. However, we double counted some people. We double counted the people that flew and play soccer. And we need to take 3 away from that. And if that's a 4, that looks like 11, 800. Say yep. All right, all right. You have 5 light bulbs. And their 5 light bulbs, they have proven, are 98.4% reliable to last over a decade because they're the new fancy kind. What is the probability that they all last over a decade? Okay, what is the probability the first light bulb lasts over a decade? Here's the next light bulb that it also does. Say, I get it. The probability 5 light bulbs. The probability is 0.984. The probability that they all last is approximately 92.3%. What is the probability that at least one of them fails? 100% minus that. So like 7.75. Cool. And finally, all right. You have a vending machine with 12 flavors for a week. Random people push a random button for 1 week. It's for 7 days. First probability, the probability that they are all different. Probability that they are all different. The first person comes in, so we got a machine with 12 different things. Somebody just comes in, pushes a random button. The probability the first person is different, well, they could choose any of the 12 because they're the first person. It's going to be different than the next person. Next one comes in. 11 of those would be different. The next person comes in, and this goes on for a week. One, 2, 3, 4, 5, 6, 7 days. You could just multiply this, divided by 12 to the 7th power, or this turns out to be, out of 12, a permutation of picking 7 over 12 to the 7th power. That number turns out to be a percent. And then if the question instead said the probability that at least 2 people pick the same, you go 100% minus that. There is your very fast refresher. Goodbye to these people here.